Hello everyone. I welcome you all in the next lecture of 12th class NCERT mathematics. In this video lecture, we will discuss question number 18 of exercise 5.1. So without further ado, let's get started. So here question says that for what value of lambda is the function defined as f of x equals to, if x less than equal to 0, then we have this thing lambda x square minus 2x, and if x is greater than 0, then we have 4x plus 1. They are saying for what value of lambda this function is continuous at x equal to 0. Okay. And next thing, actually this question has two parts. The first part is for what value of lambda this function is continuous, and the second part is check its continuity at x equal to 1. Okay. So how we can proceed in this question? So first of all, a part we need to discuss. Okay. So here they are saying the function is continuous for what value of lambda. So it means that to find the value of lambda given that f is continuous at x equal to 0. And what is the meaning of continuity? LHL equal to RHL equal to function value. Okay. How we can find this thing? LHL limit x tends to 0 negative f of x, limit h tends to 0 f of 0 minus h, limit h tends to 0 f of minus h. Now from the given function as they define, it is a piecewise function actually. Okay, in two pieces it is defined. The left side of 0 defined by the lambda x square minus 2x, and the right side of 0 defined by 4x plus 1. So as h is a h is a positive quantity, but it is very small, very infinite times small, infinitesimally small. So here we can say that limit h tends to 0. So minus h becomes a negative quantity, no? Minus h becomes negative quantity. So it will be lambda this thing we have. Okay. Now limit h tends to 0. What we are getting here? H square plus 2h or not? Okay. Now if we apply limit, what we are getting? We'll get 0 here. This is your LHL first equation. Now we need to find the function limit, right hand limit we need to find. How we can find that one? RHL we can find as limit x tends to 0 plus f of x, limit h tends to 0 f of h. 0 plus h is h, limit h tends to 0, and the value of f of h we can find by the second piece, by this one piece. So by this one piece, how we can find? It is 4h plus 1. So if we apply limit, we get 0 here. I think you understand that how we find here LHL and RHL. Okay, but we observe that one condition here, that LHL is 0, RHL is 1. From first and second, we have LHL not equal to RHL, LHL not equal to RHL. So it means that limit x tends to 0 fx, limit x tends to 0 fx does not exist. So what it implies that here we assume, this is our assumption, that There, to find the value of lambda, here, wait one more. Here we observe that to find the value of lambda given the function f is continuous. Okay, they are saying that for what value of lambda the function is continuous at x equal to 0. So for that we need to find LHL, RHL and f of 0 and we will equate them. But problem is that LHL came 0, RHL came 1, LHL and RHL both are independent of lambda. And if we find the value at 0, it will be f of 0 is 0 also, because this thing we can find by the first branch. So f of 0 is 0, LHL is 0, RHL is 1. If we equate them, we observe that LHL not equal to RHL and no, LHL is not equal to RHL. Hence the limit is not exist. If limit does not exist, implies that f is not continuous at x equal to 0. If function is not continuous at x equal to 0, it means that there is no value of lambda for which the function is continuous. There is no value of lambda for which f is continuous at x equal to 0. There is no value of lambda for which f is continuous at x equal to 0. I hope you understand, because here we observe that LHL and RHL both are independent of lambda. If they are independent of lambda, LHL is constant, RHL is constant, that is 0 and 1 respectively. So we can't find the value of lambda. Okay, and one more thing also here you can observe that LHL and RHL both are unequal, hence the limit does not exist. So limit does not exist, the function is not continuous at x equal to 0. Now the second part of this question is we need to discuss about its continuity at x equal to 1. So we'll discuss the continuity of the function at x equal to 1. Here I will find LHL limit x tends to 1 f of x limit s tends to 0 f of 1 minus h limit s tends to 0. How we can find 1 minus h value? 1 minus h we can find by the right side of the branch. Why so? Why we are doing this thing? Because h is a very small positive quantity with respect to 1. Okay, so minus h becomes the very small positive quantity with respect to 1. So if we are subtracting, see here, if we have this real line, okay, here you have a 1, here you have a 0. So 1 minus h has to be on the right side of 0 or left side of 1. Right side of 0, left side of 1, it can't exceed 0. It will not go, it will never go beyond 0, behind the 0. Understand? So that's why f of 1 minus h we have 4 1 minus h plus 1, and if we apply limit, first of all we will simplify it, limit h tends to 0 4 minus 4h plus 1, and here we are getting 5. This is your star 1. Okay, this is your star 1, this is our LHL. Now we need to find its RHL. How we can find its RHL? RHL we can find as limit x tends to 1 positive f of x we have, and here limit h tends to 0 f of 1 plus h, and again you observe that here you have a 1, here you have a 0, 1 minus h has to be in between. Okay, it will not be on the 0, behind the 0. Okay, and 1 plus h where? Because h is a positive quantity, so 1 plus h is greater than 1 or not. It means that 1 plus h is here. Here you have 1 minus h, here we have 1 plus h. 1 plus h is right side of 1, and it means it is right side of 0, it is greater than 0, and hence we have, how they define the function? Function they define 4x plus 1. So it is 4 times 1 plus h plus 1. So it will be limit h tends to 0, 4 plus 4h plus 1. If we apply limit, we will get 5 here. So this is your RHL, it is our star 2. Okay. Now we observe that one thing. What we need to observe here, we need to find the value of f of 1. F of 1 is also right side of 0. So we need to find the value by the same. That is 4 into 1 plus 1. Okay, its value is 5 also. So we observe that from LHL, function value, and the RHL, what we have, LHL equals to RHL equals to f of 1 implies that f is continuous at x equal to 0. X equal to 1. At x equal to 1 we are checking. Okay, so I hope you understand each step. Okay, so this is your B part in this question. This is your B part. Okay, and this is our A part here. Now I'll give one recap of this question, what we did in this question. For what value of lambda is the function is continuous? We need to find those value of lambda for which this function is continuous. But problem is that, so if we are finding the value of lambda for which we need to take the function is continuous, but both the problem came that when we find the LHL and RHL, they both are independent of lambda. Okay, LHL came independently 0 and RHL came 1. So LHL is not equal to RHL for any value of lambda. If you put any value, any real value of lambda, we always get LHL 0 and RHL 1. Okay, so it implies limit does not exist. If limit does not exist, then function is not continuous. Okay. Now next thing, we need to prove that we need to check what about the continuity at x equal to 1. So we need to check the continuity at x equal to 1, and we have LHL, RHL, and the function value are same. Hence the function is continuous at x equal to 1. So I hope you understand each step of this question. If you have any doubt, then you can do comments. I will rectify your query there. Thank you for watching.